Chapter 12, Time and Motion. You will learn about measuring time, the simple pendulum, motion, speed, distance, time graphs. Introduction. Time is a moment or duration in which things occur. It plays an important role in planning our activities. We usually measure time with the help of clocks and watches. Motion is a change in position of an object with respect to time. If the position of an object is not changing with respect to the time, it is said to be at rest or stationary. You have learnt about different types of motion in class 6. Measuring time. It is important to measure time so that we can be on time for events and know how long it takes to do something. Even the early man realized this need and did his best to devise ways and means to measure time. The earliest method of measuring time made use of some natural events which repeats regularly or periodically after fixed time intervals. For example, the time from one full moon to the next full moon was called a month. The time from one sunrise to the next sunrise was called a day. As time passed, human-made devices such as sundial, sand clock and water clocks to measure time. Sundial. It is based on the fact that the shadow of an object changes its position and length with a change in the position of the sun in the sky. Sundials can tell the time accurately, but a limitation of the sundial is that it cannot be used after sunset or on a cloudy day. Some historical sundials still exist in India. Maharaj Jai Singh designed and got constructed 5 Jantar Mantar, one each at Jaipur, Mathura, Delhi, Ujjain and Varanasi. The one in Jaipur is the largest of all, whereas the one in Mathura is almost in ruins. Do you know, Jantar Mantar in Jaipur is a fascinating astronomical observatory. This is one of the largest observatories in the world. This is enumerated as a World Heritage Site by UNESCO. Sand clock or hourglass. The sand clock uses the flow of sand to measure time. It is said on the principle that a definite amount of sand takes constant time to pass from one bulb to the sand to another. When the sand clock is to be used again, it is turned upside down so that the sand containing bulb comes at the top. The sand clock is usually filled with so much sand that it takes an hour to fall from the upper bulb to the lower bulb. That is why it is also called an hourglass. Sand clock cannot tell the time of day. It can only measure intervals of time. Water clock. A water clock uses the rate at which water drips from one vessel to another to measure time intervals. Every time the upper vessel is filled with water, the water takes exactly the same time to drip into the lowest vessel. Units of time. The SI unit of time is second. The larger units of time are the minute and the hour. The bigger units of time for expressing longer time intervals are day, month and year. Table 12.1 lists some important units of time. 1 minute is equal to 60 seconds. 1 hour is equal to 60 minutes. 1 day is equal to 24 hours. 1 year is equal to 12 months or 365 days. Leap year 366. 1 decade is equal to 10 years. 1 century is equal to 100 years or 10 decades. 1 millennium is equal to 1000 years. The simple pendulum. The simple pendulum consists of a small metal ball called bob suspended by a long thread from a rigid support such that the bob is free to swing back and forth. The to and fro motion of a simple pendulum is an example of periodic motion. The length of the thread from the point of suspension to the center of bob is called length of pendulum. The position of bob of the pendulum when it at rest is called its mean position. In the given figure, A is the mean position of the bob. If the bob of pendulum is pulled to one side and then released, it will begin to oscillate to and fro like a swing. Extreme position is the position of the bob at the maximum distance from the mean position. Position B and C are the extreme positions of the bob. One complete to and fro movement of the bob is called an oscillation. The motion of bob from its mean position A to B, then from B to C and back to A is equal to one oscillation. The pendulum also completes one oscillation when the bob moves from one extreme position B to the other extreme position C, comes back to position B. The time taken by a pendulum bob to complete one oscillation is called time period of a pendulum. The time taken by a bob in going from position A to B, then from B to C and back to A is the time period of the pendulum. To find the time taken by one oscillation, we measure the time taken by a large number of oscillations, say 20. Dividing the total time by the total number of oscillations, we get the time of the pendulum. The time period of a pendulum depends on its length. As the length of the pendulum increases, its time period also increases. The time period of a pendulum of given length is constant. Therefore, the length of a simple pendulum can be altered to get a certain time period. Pendulum clock. Galileo Galilei 1564 to 1642 is said to have suggested the use of pendulum as a method of measuring time in 1641. However, Christian Huygens invented the first pendulum clock in 1659. The periodic motion of a pendulum is used to make a pendulum clock for measuring time. When the pendulum swings continuously, its upper end drives some toothed wheels, which in turn moves the hour hand, minutes hand and seconds hand on a dial of the clock, due to which we are able to read time. The pendulum of a clock completes one oscillation in 1 second. When 60 oscillations are completed, the time moves by 1 minute. The pendulum clocks are not much used these days because they are big and bulky, so they could not be carried everywhere else easily. A simple pendulum of length approximately 1 minute takes exactly 2 seconds to complete one oscillation. Such a pendulum is called the seconds pendulum. Do you know, one of the largest pendulum clock in the world is the Big Ben at the House of Parliament in London, UK. Science fact. Speed of some common land animals. Cheetah 110 km to 120 km per hour. Lion 80 km per hour. Horse 48 km per hour. Giraffe 50 km per hour. Elephant 25 km per hour. Garden snail 0.047 km. Use of quartz crystal. The quartz and watches which are used nowadays are based on a quartz controlled mechanism. Quartz crystal vibrate periodically. These regular vibrations or oscillations of a tiny quartz crystal are used to measure time very accurately. These clocks and watches are also called electronic watches. A quartz clock is much more accurate than a pendulum clock. The quartz clocks and watches can be of two types: digital and non-digital. The non-digital electronic clocks and watches have hours, minutes and seconds, hands which move on a dial. The digital electronic clocks and watches display the time directly in digital on the face of the watch. Digital watches do not have the traditional hours, minutes and seconds hands. These watches use a tiny button-sized electric cell for their working. Motion. A continuous change in the position of an object with respect to its surroundings in a given interval of a time is called motion. Sometimes a body that appears to be in motion in relation to one observer may appear to be at rest in relation to the other observer. For example, a person sitting in front of you in a moving bus will appear at rest, while both of you will seem to be in motion to the person standing outside on the road. In other words, we can say that motion can rest and relative terms because they depend on the observer's frame of reference. Thus, if two different observers are not at rest with respect to each other, then they get different results on observing the motion or rest of the body. Speed. We see many moving objects around us, but how can we decide which one is moving faster? Speed is a measure of how fast or slow an object is running. An object which takes longer time to cover a certain distance is called slow, whereas another object which takes shorter time to cover the same distance is said to be fast. The distance traveled by a moving object in unit time is called speed of the object. To find the speed of an object, we divide the distance traveled by the object by the time it takes to travel the distance. Speed is equal to distance covered divided by time taken. The SI unit of speed is meter per second. The speed of fast moving objects like cars, trains are measured in kilometers per hour. To convert the unit of speed from m upon s to kilometer upon hour, we convert meters to kilometers and seconds to hours by using the following formula. 1 meter per second is equal to 1 upon 100 kilometer divided by 100 upon 3600 hour is equal to 3600 divided by 1000 kilometer per hour is equal to 18 upon 5 kilometer per hour. To convert from kilometer per hour to meter per second, we use the formula 1 kilometer per hour is equal to 1 into 100 meter divided by 1 into 3600 hour is equal to 5 upon 18 minute per second. Example, a bus takes 7 hours to cover the distance of 308 kilometer. Calculate its speed. Solution, time is equal to 7 hour, distance 308 kilometer. Speed, distance covered upon time taken. Speed is equal to 308 by 7 is equal to 44 km per hour. Example 2. The Duronto Express takes 19 hours to travel from New Delhi to Pune at a speed of 80 km per hour. Find the distance between New Delhi and Pune. Solution, time is equal to 19 hours. Speed is equal to 80 km per hour. Distance is equal to S into T. 80 into 19 is equal to 1520 km. The distance between New Delhi and Pune is 1520 km. Example 3. A car takes 40 minutes to cover a distance of 36 km. Calculate its speed in km per hour and meter per second. Speed is equal to distance covered by time taken is equal to 36 km divided by 40 minutes is equal to 36 km divided by 40 upon 60 meter is equal to 36 into 60 divided by 40 is equal to 54 km per hour. To convert 54 km per hour in meter per second, speed is equal to 54 into 5 upon 18 meter per second is equal to 15 meter per second. Speedometer and odometer. Speed of moving vehicles, cars, motorcycle, scooters, buses, etc. at an instant is recorded and displayed using an instrument called the speedometer. This is fitted on the dashboards of vehicles. This gives the speed of moving vehicles in kilometer per hour. There is another meter generally fitted within the speeds meter known as odometer. It is used to record the distance travelled by the vehicle in kilometer. Uniform motion. The moving body is said to be in uniform motion when it covers equal distance in equal intervals of time. During a uniform motion, speed of the body and direction of motion does not change. Uniform motion of a body is illustrated below. Do you know fastest bird? Peregrine falcon, 320 km per hour. Fastest man? Usain Bolt, 44 km per hour. Fastest motorcycle? Dodge Tomahawk, 560 km per hour. Fastest fish? Sailfish, 105 km per hour. Fastest train? TGV train, 574.8 km per hour. Non-uniform motion. A moving body is said to be in non-uniform motion when it covers unequal distance in equal intervals of time or vice versa. Hence, the body is said to be moving with non-uniform speed in a straight line. Non-uniform motion of body is illustrated below. Distance time graph. The distance travelled by an object over a period of time can be plotted on a graph called distance time graph. The distance covered by the object is recorded on y-axis and the time taken by the object cover that distance is recorded on the x-axis. Distance time graph for uniform motion. The graph between distance covered and time taken for an object having uniform motion is always a straight line graph. The slope of a distance time graph indicates the speed of the object. If the distance time graph has low slope, then the object has low speed. If the distance time graph has a high slope, then the object has higher speed. Distance time graph for non-uniform motion. The distance time graph for an object having non-uniform motion, non-uniform speed is a curved line. Thus, a curved line graph between distance and time tells us that object is moving with a non-uniform speed. Distance time graph when object is stationary. The distance time graph for a stationary object is straight line parallel to the time axis, x-axis, because when the object is stationary, the distance travelled by it does not change. In this graph, it is parallel to x-axis as seen between 10 seconds and 15 seconds. Key terms. Simple pendulum, a small metal ball that is suspended by a long thread from a rigid support such that bob is free to swing back and forth. Quartz, a hard shiny crystal used in making electronic watches and clocks. Speed, distance travelled by an object per unit time. Speedometer, an instrument that measures and displays the instantaneous speed of a vehicle. Odometer, an instrument for measuring the distance travelled by a vehicle. Uniform motion, a type of motion in which the object covers equal distances in equal intervals of time, irrespective of the duration of the time. Non-uniform motion, a type of motion patch, a type of motion in which the object covers unequal distances in equal interval of time. Quick recap. The earliest method of measuring time made use of natural events which repeat periodically after fixed time intervals. Some instruments used in the ancient times for timekeeping were sundial, sand clock and water clock. A simple pendulum consists of a small metal ball suspended by a long thread from a rigid support such that bob is free to swing back and forth. A simple pendulum is used to measure time and shows periodic motion. The time taken to complete one oscillation is called the time period of the pendulum. The distance travelled by a moving object in unit time is called speed of the object. An object is said to have uniform motion if it covers equal distances in equal intervals of time. An object is said to have non-uniform motion if it covers unequal distance in equal intervals of time. The distance time graph for uniform motion is always a straight line. The distance time graph for non-uniform motion is a curved line. Chapter 3.